Hello and welcome to TCAD Centaurus video tutorial, Centaurus Structure Editor, Section 2, Generating 2D Boundaries. This video is the first of a 3-video episode series illustrating the process of building a 2-dimensional, partially depleted SOI device structure. In this video, we create a boundary of the device and define contacts. This is the structure we are going to build, with the gate contact replacing polysilicon gate region and a body tie contact. In the subsequent episodes, the doping definition and mesh refinement will be covered. To start the tool, type SDE in a terminal. The default coordinate system for Structure Editor is selected in such a way that the y-axis is horizontal and x-axis points down. In this tutorial, however, we will follow a so-called DFISC coordinate system, where x-axis is horizontal and the y-axis points down. Coordinate system axes are shown at the bottom left corner and can be rotated using Views toolbar buttons. Pressing X-Y button selects the desired view. To ensure precise alignment and prevent gaps in the structure between different regions, activate Exact Coordinates mode. The pressed button indicates that the mode is active. To start the process of building MOS device structure, we define silicon substrate using rectangular region drawing tool. Hovering the cursor over the button shows the function associated with the button in the toolbar ribbon. The drawing functions are also accessible using Draw 2D Create Tools in drop-down menu. Since the exact coordinate mode is turned on, the program prompts to refine the values of the coordinates for the rectangular region. Next step is defining a gate oxide region. First, we need to change the material to oxide using material list. All materials defined in Datex code file are available to Centaurus Structure Editor and are accessible from the material list. Creating rectangular oxide region, type the coordinates of the corners in the exact coordinate box. Next, we define nitride spacer. As before, change material to nitride and create nitride block. Next step is creating polysilicon gate region. This is also a good time to comment on Boolean overlap operations. When creating a device with multiple regions in Centaurus Structure Editor, later added regions might intersect existing regions. If this occurs, a predefined scheme is used to resolve the overlapping of the regions. To select the overlap resolution behavior, choose Draw Overlap Behavior, or click the corresponding toolbar button. The default overlap resolution behavior available in Centaurus Structure Editor is New replaces Old. When this mode is selected, the part of the old structure that overlaps with the new one is deleted, and the boundary is replaced by the boundary of the new region. In addition, Old replaces New, Merge, and some other options are available. Change material to poly and create rectangular region. As you can see, newly defined polysilicon region replaces part of the nitride, splitting it into two. Boolean overlap resolution behavior is a very powerful tool in creating complex structures. Similarly, change material to oxide and define buried oxide layer. In the next step, we're going to round the corners of nitride region. Centaurus Structure Editor includes functions that round the corners and edges of the structure. Change the selection type from the default body to vertex using Selection Level List. Select a vertex by either clicking on it or drawing an area around it. Next, choose Edit 2D Tools Fillet to round the corner. The dialog prompts to enter the radius of the rounding. We enter 0.08. We repeat the operations to round the nitride corner on the other side of the device. Since we are using the same radius, we could have rounded both corners at the same time. Let's undo the last two steps. Select both corners, pressing and holding Control button, and round the corners together. The boundary of the structure is now built, and it is time to define contacts. To define a contact, choose Contact Sets. The Contact Sets dialog comes up. Type the name of the contact. The color in which a contact is rendered is given by the next field. This is a standard RGB. We keep the default red color for the source. Larger than 1H thickness ensures that the contacts are highly visible, and we leave thickness as 4. Face pattern is only applicable to 3D. Click on Set button, and newly defined contact shows up in the list of contacts. In a similar fashion, define drain contact using green color. We define substrate contact using yellow. Body tie contact using purple. And we use blue color for the gate. Next step is to associate a defined contact from the list with an edge or region boundary. We will start with source contact. Highlighting source in the list and click Activate button. Also, switch Selection Level List to Select Edge mode. Make sure that the Select tool is chosen. Click on top left edge of the silicon region to highlight an edge for source contact. Then go to Contact drop-down menu. Set Contact option to set the contact. The edge is now defined as the source contact and shown with thick red line. We repeat the same steps to define drain contact. Contact list can be used directly to choose and activate contact. Close Contact Set dialog and activate Substrate contact. For the simulation of 2D SOI MOSFETs, artificial body-tight contacts are sometimes useful. These contacts are placed typically at the interface between the silicon epi layer and the buried oxide, near the source side of the gate corner. Before such contact can be defined, 2 additional vertices must be introduced to create an edge. Use drop-down menu option Edit 2D Edit Tools, Add Vertex, or click Add Vertex button, Toolbar button. Click location where we want new vertex to be inserted. Exact coordinates dialog comes up. Insert one vertex at -0.1.1 and another at -0.05.1. Now we have a new edge that can be associated with body tie contact. Activate body tie contact, switch the tool to selector, highlight the edge, and define contacts with Set Contact option. In some applications, a contact can cover the entire body of a 2D region. For example, metal and polysilicon regions of an MOS device are often treated as ideal contact. We follow the same approach in this demo. First, activate gate contact. Change selector type to select body. Select gate poly region and set contact to region boundary edges. This converts the selected region boundaries into a contact. As you can see, the edges of the region change to the color and style of the selected contact. To avoid the need for solving Poisson and carrier continuity equations in device simulations in poly, remove poly region. To remove polysilicon region from the model, select poly region and then go to Edit, 2D Edit Tools, Delete Region, or just press the Delete button. The final step is to save the model. Use a standard file menu. Only the root of the file name needs to be specified. No extension specification is necessary. The model is saved in a native ASIC file with .sat extension, and the boundary is written into a TDR file with bnd.tdr extension. This concludes the first video in a series. I hope you have found it useful. In the next video, we define doping profiles for this partially depleted SOI device. Thank you for watching.